morning. Good morning, Mr. Bishop is here, and I'm today here to remind you very quickly of the functions we've done last year. Okay, we're starting a new chapter function. We're going to add quite a bit to it this year, but the first part is just to remind you what we've done already. Okay, we've looked at, I've got 5 graphs here, but it's really 4 types, 4 families of functions. Okay, and let's see if you remember. Okay, I'm just going to change that one. Okay, I'm dealing right now in what we call mother graphs. Okay, so the mother graphs are your, how should I say, like each family has one graph. We call it the mother graph, and all the other versions of that graph come from it. So we'll start with this one, straight line. Anyone remember what that is called? Linear. Good. You can definitely use, we're in page 51, so you can look and you can tell me, you can feel very good about yourself. It's awesome. Okay, this one is called linear. And more importantly, how do we write it? You know, every graph can be represented as a function of y equals something to do with x. So y equals x. That's the most simple linear function. In fact, the most simple function there is. Given a y is simply the same x. So we'll go through these points of, let's say, 0, 0, okay, 1, 1, and so on and so on and so on. Y equals x. We happy with that? Cool. Next one. Then we looked at that one. What were these called? That's parabolas, not hyperbolas. These are parabolas. Okay? And they come from quadratic function. And the most simple, basic quadratic function is y equals x squared. Okay? So when we got y equals x squared, that's the mother graph for a parabola. It's basically this smiley face. Are we happy with that? Okay, cool. Right. Now we're moving to the hyperbolas. These guys are hyperbolas. And they've got a funny way. It's y equals 1 over x. Now this is quite new. This is quite different. Okay, but we have come across that. We're introducing this new concept called, or when we learned that it was new, asymptotes. Okay, remember that business with asymptotes? There's 2 asymptotes here. A horizontal asymptote and a vertical asymptote. And the business with these asymptotes is that the graphs constantly getting closer and closer and closer to them, but they actually never reach them. Okay, that line gets closer and closer, but it never reaches it, let alone it obviously doesn't cross it. Okay, so that's a horizontal asymptote. We also have a vertical asymptote when the lines here get closer and closer and closer to it, but they never really reach it. Okay, right, that's a hyperbola. What are these guys called? Do you remember?
These are exponential.
These are exponential. Well done. And we've got two of them. Exponential. If you remember, I call them an airplane taking off and an airplane landing. Okay? And the mother function is y equal ax. Which a do we use? I can't even remember. Yeah, we don't have. So it's basically b to the power of x. Okay, we use the letter b. Okay, where b is larger than 1. If b is larger than 1, the airplane is taking off. For example, I think the one I normally use actually is y equal 2 to the power x. That's how I start that. So 2 to the power x, 2 to the power 10, 2 to the power 20. Every time you're making x bigger, it just gets bigger and bigger and bigger and bigger and bigger. It takes off. Okay? Where if you go 2 to the power of minus 100, what is 2 to the power minus 100? It's 1 divided by 2 to the power of 100, which is a very small number. Okay? It's 2 to the power of 100 is 2 times 2 times. That's a very large number. If you have 1 divided by a very large number, you get a very tiny little number. Okay? Right. We have a horizontal asymptote here. Okay? This line, as you go to x approaches infinity, it never really crosses x-axis. Okay? On the other hand, if you take y, okay, equal b, the same, b to the power x, but now b is between 0 and 1. It's like a fraction. The example I usually give is y equal half to the power x. Okay? Which is the same if you think about it, 2 to the power minus x, because half is 2 to the power minus 1. 2 to the power minus 1 to the power of x is 2 to the power minus 6. Okay? And when I make x big, let's say 2 to the power minus 100, that's 1 divided by 2 to the power of 100, that is a very, very small number. So now the plane is landing, okay? It approaches this same horizontal asymptote. If I put a very negative x, 2 to the power minus, let's say minus 100, that's going to be 2 to the power of 100, which is a very large number. So the airplane was very high here and now it's landing. I'm just going to pause here and see if you've got anything to ask. So that's using these mother graphs, now we can create varieties. For example, I can take this boring y equal x, I can multiply the x by some kind of constant, a. Okay, so ax. And in fact, I can add a q. Right? Now, we learned these things last lesson. The a really is the gradient. It's the slope. Okay? So if, for example, just for the fun of it, a is negative, what will happen to the graph? Is it going to go up? It's going to start going down now, right? If it's minus 3x, you remember minus 3x is the graph that goes down. Does that ring a bell? Okay? And then I can even add a q. Okay? And a q is what we call the y-intercept. Okay? So this is going to be your gradient, and this is going to be the y-intercept. It's all stuff that we, believe it or not, we actually learned it. In fact, even in grade 9. Okay, that was the one thing we studied in grade 9. Okay, so the q is the y-intercept, or sometimes we can call it a vertical shift. That's a good word to learn. Okay, q is something that pushes up and down the graph. I mean, think about it. If from y equal x I move to y equal x plus 2, what will be the y? Everything basically moves up 2, up. When x is 0, what is y now? If x is 0, y will be 2. If x is 1, y will be 1 plus 2, 3. So that boring graph that was 45 degrees just moving up 2 units up. It's a vertical shift. If I have x minus 2, what is the vertical shift? Down 2 units. Yeah? Okay, and that's the same process for all of them. Okay, I can say y equal ax squared plus q. The q is the vertical shift. Okay, if I'm doing minus 3, what will happen to that graph?
Go down.
It will go down 3 units, yeah? Right? But if I'm doing, let's say, if I, just for example, y equal, let's take an example, 2x squared minus 3. So this graph is going to be pulled down. But first of all, we multiplied by 2. If you remember, okay, we did teach it last year, okay, a larger A means that it's becoming more narrow. It's more steep. Just like here, larger A becoming more steep. This is stuff we learned in grade 9, okay? And negative A means it goes down, positive A goes up, larger A means it's becoming more steep. The same thing here. A makes it more steep. So this graph will be something like this. Okay, it will be more narrow, more steep everywhere, and it's going to move down 3 units. What will be the y-intercept here? What is it going to cross here?
Minus 3.
At minus 3. Good. Okay. Right. Moving on to here. Okay. What did we do with that? We said, okay, let's take this mother graph and turn it to y equal a over x plus q. Again, the q in all these cases is basically a vertical shift. If it's positive, it goes up. If it's negative, it goes down. The a makes it get more steep. So if I'm looking at a specific example, y equal 2 over x minus 1, okay? Then the new horizontal shift, the new horizontal asymptotes, everything is just basically moving down. So now it's going to be here at minus 1, and we're going to have the new graph is going to be something like this. Okay, it's going to all be shifted down, and the 2 is going to make it a little bit more steep. Right, moving on to here. What we've done here, we took this graph, let me get rid of that, and we said, okay, I just want to use the same letter as them, okay, and Q. A times b to the power x, the same thing, and now we're adding Q. Again, Q is just a vertical shift, moving it up or moving it down. The A, as in all these cases, makes it a bit more steep, okay, or less steep, depends what A I'm choosing, okay. But I'm going to choose actually a negative A. For example, let's look at minus 2 to the power x plus 1. So the plus 1, what does the plus 1 do? Push it up 1. By the way, I didn't ask you, what is the y-intercept now? If I'm just using the graph y equal 2 to the power x, what will it cross here? 2. If I put x equals 0, what will I get? What is 2 to the power 0?
1.
1. So if I don't have anything in front of that b, it's always going to, the y-intercept is going to be 1. But if I'm putting plus 1, everything is going to move up 1, right? But what does the minus do? I don't know if you remember that one.
Let's take it down to inverse.
Well done, G. Well done. Whenever you stick a minus here, it flips it around. So the new y-intercept, the vertical shift means it's going to be at 2, but now the graph is going to be inverted down. Well done, okay? It's going to be, what will be the, hang on, I'm a little bit lost here. Okay, so it's going to, a bit lost, okay? So the new horizontal shift has moved 1 up. So first of all, let's draw the horizontal shift. It's going to be like that. That's it. And now, here's my one. So first of all, I'm flipping it. Yes. And then yes. Okay. So it's going to be like this. No, don't think it's wrong. Just going to pause here for a second, think about it. Okay, so thought about it a little bit. It wasn't too long, was I? 3 seconds. So what I'm going to have to do first of all is by putting the minus, I basically flipped it. This was how the graph looked like. And now I shifted it up. So the graph would look like if I put this 0, it would be at 1. No, hang on. Why am I doing it? Something's wrong again. If I put 0 here, what is minus 2 to the power 0? 1. But because I've got a minus 1, it will be minus 1. Because I have a minus, so it will be minus 1. Minus 1 plus 1 is 0. So it's going to cross here. So I was wrong when I said it's going to be here. It's going to be just like that. Okay.
So it's not going to
move
cross 1, but it's going to cross over.
Yes, yes. And the y-intercept is at 0, not at 2. I was wrong. I can do the same thing here. I know I'm jamming it here, guys, but you will have at home to look at some more of the question you got in grade 10. You're going to have to revise this. There's not enough time for me to go through all these things in more details. I'm just scanning through it, just hopefully try and remind you some stuff. Okay, the mother graph here, what we're going to do is the same. Well, we're doing the same thing. Okay, so a times b to the power x plus q. Again, q is the vertical shift, and A controls whether it's steep or not steep, or like Eugene said now, if it's negative, it actually inverts it. Okay? I'm going to pause here, and we're going to straight away go into grade 11 level. I know it sounds a bit overwhelmed, but as we practice these grade 11, the new stuff, you will have, I'm hoping, some time to remind yourself of all that stuff that I just mentioned. I'm actually going to close this video now. We're going to start a new whole video. Cheerios.